Sup, Mr. Lee here. This is your Khan Academy tutorial for linear and nonlinear functions. So we could be getting information about a function either in its graph, equation, or table form, and our job is to figure out if it's linear or nonlinear. Okay, so here's the first one. Does the graph shown represent a linear function? The answer to this would be no, even though we have these three separate lines or line segments. For a linear function to be a linear function, you have to have a single line throughout the whole thing, okay? So even though this is separate lines, it's not one single line, so we'll still say no. All right, this one is a single line. All right, so graphs should be the easiest to identify if it's a linear function or not. So this is a line, yes. This one is a table. So could the table of xy pairs have been generated by a linear function? So we have to look at the rate of change, right? The slope. If your slope is constant, or if your slope is the same throughout the entirety of the points throughout the graph, then we know it's a linear function. Okay, so we can test this. The change in y for this first set of points is -1 over a plus 4. Okay, so we have a slope of 1 over 4 essentially for this first set of points. If, sorry, -1/4, this should be the slope. If we can confirm that all the other slopes between any pairs of points in this table are also -1/4, then we can conclude it's a linear function. If we get something different than -1/4 at any point, then it's a nonlinear function. Okay, so let's just keep going down the line here. This is going to be from 3 to 2. That's another -1. That's going to be a -3 to 1 is also a +4. So we're looking good. Let's do one more here. From 2 to 1 should be a -1 as well. Looking good so far. But then, hey, check this out. From 1 to 7 is a +6. Okay? So between the first set of points, we have a slope of -1/4. Between the second and third points, we have a -1/4. But between the third and fourth, we have a -1/6. So they're not trying to be tricky. They just want to make sure you're checking all of the points. Okay, so this one's actually not a linear function because it changes. The slope or the rate of change is different than some of the other point combos. So it has to be the same throughout the whole thing. Make sure you check each. Okay, now the graph should be relatively easy. This one is obviously some kind of curved function, so we can say it's not linear. It does not produce a line. Okay, let's just do one more here. Does the graph shown below represent y as a linear function? So same thing. This is a kind of a wave curve. So this one's no. We've been getting a lot of graphs, so maybe I'll do one more here. The graphs, again, are the easiest ones. Okay, so we'll do one more table here. So could the table of xy pairs have been generated by a linear function? So let's test the same thing, right? Just go down the line here. We're going, what, a +2 in the y direction between the first and second point. This is a +1. We have another +2 over +1. And I think you guys can kind of see this one should be good. Working with slightly easier numbers. So all around, we are going +2 over +1. Right? So the slope should be consistent, changing y over changing x. The slope throughout the whole set of points, no matter which 2 points we pick, should be 2 over 1. So this one is actually good. So we're going to press check there. All right, so that should be enough for you guys to complete this exercise.